Hi everyone, today we will revise all past paper questions related to chapter 5 from 2016 to 2025. I will cover all the questions so you can see one by one. Before starting the question, you need to remember these three formulas. It will save your time because all the questions in the exams are related to these formulas. And you must know the tricks where you have to apply these formulas. First of all, if in the reaction, they will give you a reaction and they ask you about to find the mass or whatever the molar mass, then and they all the in the reactions all the elements or all the compounds are actually the solid, then you have to use this formula. Moles is equal to given mass divided by molar mass. The molar mass usually you can find from the periodic table, whereas the mass or mole will be given in the question. For solutions, if you have some solutions or the liquid in your reaction, then you have to use this formula, and especially in the question they will give you concentration or volume. So from there you can easily assume that this question needs this formula. Moles is equal to concentration into volume, and remember that volume is usually measured in dm cube. It is the standard unit. But if you did not get the question in the question, if you don't get the volume in dm cube, then you have to convert it in dm cube before starting your calculations. And the third formula is for the gases. If the gases are in the reaction and they give you some pressure, but sorry, not the pressure, they give you some volume, then remember that you have to divide it by 24, because at standard room temperature and pressure, the concentration of the gases is usually 24 moles per dm cube. Okay, so 24 mole per dm cube is the concentration of the gases at standard room temperature and pressure. They will not give you in the exam, but at the end of your periodic table, in one line they will tell you that the gases at room temperature and pressure have a concentration of 24 dm cube. Okay, so this is the formula. Moles is equal to volume divided by 24. Okay, so you can also reshuffle these formulas to find whatever you want to find. If you want to find volume, for example, you can just multiply moles with the 24, right? So you can find the volume. So this is how you have to remember these formulas. So whenever you are starting a paper in the exam, first of all you have to write these formulas on your questions paper so you don't forget anything. Then you can start doing your question. Okay, so let's start the question number 1. Magnesium chloride MgCl2 contains magnesium ions and chloride ions. How many chloride ions are present in 2 moles of magnesium chloride? So first of all, what is important here, they are asking about the magnesium chloride, but especially about the chloride ions we have to find, right? Not the magnesium ions. Then they told you that it has we have to find in 2 moles of magnesium chloride. So it's simple. If you see 1 mole of magnesium chloride contains how many chloride ions? 2, right? So it means we have 2 moles of chloride ions. Now if we have 2 moles, then what we will get? 2 moles will contain 2 into 2. So 4 moles of chloride ions. So it's simple. 4 more of chloride ions, you have to just multiply by with the Avogadro's constant, right? Because for 1 mole, the Avogadro's constant is actually 6.02 into 10 raised to power 23. So 4 multiplied by 6.02 into 10 raised to power 23, this will be your answer. So which option is correct? Option B is the correct option. Sorry, option C, 2.41. Option C is the correct option. Okay, question number 2. Which sample does not contain a number of atoms equal to Avogadro's constant? So these are all the different options given over here. If you see for nitrogen, so nitrogen is a molecule. How many atoms it should have? At least it has 2 atoms, right? So 2 atoms, if you multiply each with 14, because 14 is the mass, so it should be 28. But here it is written 14 gram, right? So it means we have actually 0.5 mole of N2. Why 0.5 mole of N2? Because N2 1 mole should have 28 gram, but here we have now 0.5 mole because it is 14 grams. So once it's 14 gram, we know that it is 0.5 mole, right? So nitrogen, if it is 0.5 mole, you have to multiply with Avogadro's constant and you will get that how many molecules it have. It has 3.01 molecules. But if you see for the atoms, because in the question they are asking about the atoms. So how many atoms we have? 2 here. So when you multiply this 2 with this number of the molecules, you will get 6.02 into 10 raised to power 23. That is equal to Avogadro's constant. So this question, this option is right. Same for water. If you look for the water, it is 6 gram, but 1 mole of the water should have how many molecules? 6.02, right? And the mass should be 18 gram. But if you see, it is 6 gram. So the molecule number is the mole number is 0.33, because 6 divided by 18 is equal to 0.3 mole, right? So 0.3 moles will have how many molecules? 2.07 molecules. Now, if you want to calculate the atoms, you see how many atoms we have here? 3 atoms. So when 3 atoms you multiply with 2 point this number, you will get against the same Avogadro's constant. Same for the helium. Helium is 4 gram, and if you see your periodic table, the 1 mole of helium has a mass of 4 gram, right? So it means it's also 1 molar. So 1 molar will, of course, will have same number of the atoms, 6.02 into 10 raised to power 23. So we are now just left with option D. So option D is the right option. Why? Because if you see, 28 gram of carbon monoxide is actually 1 mole of carbon monoxide, right? So one molecule has 6.02 into 10 raised to power 23 molecules, but they are asking about the atoms. So how many atoms we have? 2 atoms. So if you multiply 2 with the Avogadro's constant, it will become double, 1.204 into 10 raised to power 24. It means it's more than the Avogadro's constant. So option D is the right option. Question number 4. Which gas sample contains the most molecules? So it's simple. You have to first find the number of the moles. Once you know the number of the moles, it will be easy for you, because we know that in 1 mole we have how many atoms or molecules? 6.02 into 10 raised to power 23. So now let's see one by one that which one of them is 1 mole or more than 1 mole. So if you see 24 dm cube, it's the volume of carbon dioxide, and carbon dioxide is a gas, so it means at room temperature and pressure it should be 1 mole, because only 1 mole of a gas can have 24 dm cube volume. Now we have 4 gram of hydrogen. Hydrogen mass is 1 gram, right? So it means it is actually now 4 moles. So we have 4 moles of hydrogen. Let's see for 36 dm cube of hydrogen chloride. So hydrogen chloride mass is actually 36.5, right? So it means it is also equal to almost 1 mole. So now let's see for the nitrogen. Nitrogen is 14 gram, but its mass should be 28 gram, right? Because N is 14, so 14 into 2 is 28 gram. So if it is 14 gram of nitrogen molecule, so it means it is actually 0.5 mole of the nitrogen. So which one has the most molecules? If you see, 4 moles will have the most molecules, because if 1 mole has 6.02, then 4 moles will be 4 into 6.02 into 10 raised to power 23. So that's why option B is the right option. Question number 5. Which sample contains the greatest number of the molecules? Again, it's the same question. You just have to find the moles. If you know the moles, the one which will have the more moles, it will have the more number of the molecules. Let's see, for 4 gram of hydrogen, again it is 4 moles. For 18 gram of water, the mass of water is 18 gram. Yes, so it means it's 1 mole. 24 dm cube of oxygen, so it is also 1 mole, because a gas will have a volume of 24 dm cube, only 1 mole of a gas, okay, at standard room and temperature. 66 gram of carbon dioxide, actually its mass is 44 grams, so 66 means 1.5 mole. You can easily calculate. So which one is more? Of course, option A. So option A is the right option. Question number 6. Which sample contains the larger number of molecules? Again, the same question. You have to just find the number of the moles. So if you see one by one, for methane, the molar mass is 16 grams. So it means it is 1 mole, right? For oxygen, the molar mass is also 16 grams. So it is also 1 mole. 16 gram of phosphorus. This is not right, because if you see in your periodic table how many we have, phosphorus has a mass of 31. So right, 31 should have 31 into 4. So the mass should be more than this. Okay, if you calculate, what will be the answer? So 16 gram of the phosphorus is very less, right? Let's see, for 16 dm cube of methane at room temperature, it's also less than, because 16 dm cube, if it's a gas, so 24 is means, if it is 24 dm cube is the volume, then it is 1 mole. But if it is 16 dm cube, then the mass will be so then the mole will be less than 1 mole, right? It will be less than, you can calculate. But okay, sorry, I did a mistake in part B. If you see part B, 16 gram of oxygen is not 1 mole, it is actually 0.5 mole. Why? Because oxygen is 16, right? But actually we have 2 atoms. So it should be 16 into 2, it's 32. So 32 gram will give you 1 mole, but it is 16 grams, so it is actually 0.5 mole. So we are only left with the first option A. It is 1 mole. All of them are less than 1 mole. So option A is the right option. Question 7. Which gas sample contains the smallest number of molecules? Now, here they are asking you the smallest number, not the largest number. But we have to do the same calculation. 4 gram of helium, simple. It's 1 mole, right? Because the mass of helium is 4 gram. You can see in the periodic table 16 gram of oxygen. Oxygen is usually is a diatomic molecule, so it should be 32, right? But it is 16 grams, so it's 0.5 mole. 28 gram of carbon monoxide. If you calculate the mass of carbon monoxide, it should be 28. So 28 is equal to 1 mole. 28 gram of nitrogen. Nitrogen is usually present in the form of N2, right? So nitrogen 14 into 2 will be 28. So it's also 1 mole. So who is left? Only oxygen. So B option is the right. It has the smallest number of the molecules. Question number 8. The structure of ethene is shown here. How many hydrogen atoms and how many carbon atoms in 1 mole of ethene? As simple as like the previous questions. How many carbon we have here? 2 carbon, right? And they are asking about the atoms. So if 1 mole has how many? 6.02 into 10 raised to power 23. Then 2 atoms will have how much? You just have to multiply with 2. Okay. So your answer will be 1.24 into 10 raised to power 23, or you can say 12.4 into 10 raised to power 23. You can see which option has this one. So if you see for the carbon atoms, 1.2 into 10 raised to power 23, this option A is right. You don't need to calculate for the hydrogen to save your time, but if you still want to calculate, you can see that hydrogen are double than the carbon, right? So it should be double than 1.24. So if you multiply 1.24 with the 2, what you will get? It will be 2.4 into 10 raised to power 23, right? 10 raised to power 24. So option A, of course, is the right option. Hydrogen atoms, we have 2.4, and carbon atoms, we have 1.2. Question number 9. 1 mole of silver nitrate, AgNO3, contains these ions. Okay, how many ions are there in 0.25 mole of iron oxide Fe2O3? So now they are asking about the ions. If you see here in the silver nitrate, how many ions it will produce? 1 mole. Of course, it will produce 2 ions, one Ag and the one NO3. That's why if you multiply 6.02 into 10 raised to power 23 with 2, you will get this answer, right? But we have to look for the ions now in Fe2O3. So 1 mole of Fe2O3 will produce how many ions? If you look here, Fe has 2 ions, right? 2 Fe ions, and then we will get 3 oxygen ions. So how many ions total? 5 ions we will get in total number from 1 mole. So but they have asked you in 0.25 mole how many you will get. So you have to just multiply 0.25 with 5 and then with Avogadro's constant, that is 6.02 into 10 raised to power 23. So what will be your answer? If you do all this calculation, your answer will be 7.53 into 10 raised to power 23, and this is the option C. So option C is the right option. Question number 10. Which gas sample has the greatest mass? Now they have given you the number of moles and you have to find the mass. Okay, so remember the first formula, which is for the solids. I already told you, because they have here, they have not mentioned now these are the solid. They all of them are actually the gases, right? But they have calculated it in the form of the mass. That's why they are asking you the mass. So if there is a mass, you just have to use the first formula, that is mole is equal to given mass divided by molar mass. So now here you have to find given mass, right? So what will you do? You will just multiply mole with the molar mass. That's simple. So you will just rearrange this you will just rearrange this equation, and then you will see that mole into molar mass is equal to given mass. So now let's see one by one how we can calculate 5 moles of Cl2. So what is the mass of Cl2? If you see in your periodic table, 35.5 into 2, because we have two atoms, right? So it will be 71. So how much mass we will get? 355 gram. Second, for 10 moles of oxygen mass is 32, right? 16 into 2 is 32. So 10 into 32, we will get 320 grams. Same for nitrogen, you will get 420 gram. And then 20 moles of hydrogen, you will get 20 into 2 is 40 gram. So which number is the highest number? Of course, 420 gram. So 420 gram is the greatest one, that is for nitrogen. So in 15 moles of nitrogen, we have the greatest mass, that it is 420 gram. So option C is the right option. Question 11. Which sample of magnesium chloride contains the same number of moles as of 69.6 gram of potassium sulfate K2SO4? So if you see your question, they have given you two things, two compounds, magnesium chloride and K2SO4. But information, the given information is only about K2SO4, that is 69.6 gram. And we have to find the moles, that when the mass of these moles will be equal. So first of all, we have to find the moles of K2SO4. It's easy for us because we have already given the mass. So moles is equal to, we already know the formula, given mass, okay, divided by the molar mass. So given mass is already how much? 69.6 grams. So we have to just divide it with the molar mass. And what is the molar mass of K2SO4? You have to find it yourself from the periodic table. Okay, and then you will get it's 174. Be very careful when you are calculating the molar masses. Don't miss these numbers 2 or 4, because you have to multiply them, otherwise your answer will be wrong. And once your answer will be wrong, your all calculations will be wrong. Okay, so calculate your molar masses very carefully. So now what will be your answer? If you divide, what will be the number of moles? We get 0.4 moles, right? Once you get 0.4 moles, now you know that we need 0.4 moles of MgCl2, right? Same number of moles. So if you want 0.4 moles, what you have to do? You have to find the mass, given mass for MgCl2. It's simple. Now we know the moles, we know the molar mass, but we don't know the given mass, right? So you just have to reshuffle this equation and you just multiply them, right? And you will find the given mass. Okay, so moles into molar mass, you will know the given mass. So what is the moles? Moles is 0.4, right? And the molar mass of magnesium chloride is 95 grams. Simple. So 95 into 0.4, you will get 38 grams. So 38 gram of MgCl2 and 69.6 gram of potassium sulfite both have how many moles? Same number of moles, that is 0.4. So our option C is the right option. Question number 12. Benzene is a liquid with molecular formula C6H6. Ethene is a gas with molecular formula C2H4. Which statement is correct? Now, the most important thing you have to highlight is actually benzene is liquid and gas, ethene is a gas. Okay, now let's see one by one each statement. 1 mole of benzene and 1 mole of ethene contain the same number of atoms. They both are 1 mole, so they contain the same number of molecules, that is 6.02 into 10 raised to power 23. But if it comes for the atoms, you see this one has 12 atoms, but this one has only 6 atoms, so this option is not correct. Second, a mole of benzene and 1 mole of ethene both have a volume of 24 dm cube at room temperature and pressure. So the volume will be only 24 dm cube for 1 mole of a gas. But if you see, only ethene is a gas, but benzene is not a gas. So this option is also not right. Both benzene and ethene have the same empirical formula. Let's see the empirical formula. The shortest formula we can have for the benzene is CH, right? But for this one, we will have CH2. So that's also wrong, right? Now we are just left with the option D. So option D can be right. Why? Because if you see the number of carbon atoms in 0.5 moles of ethene, how many how many carbons we will have in 0.5 moles now? We will have only, if 1 mole has 2, then in 0.5 we will have 1 carbon, right? So 1 carbon of course will be equal to Avogadro's constant, that is 6.02 into 10 raised to power 23. So this option is right. That's why option D is correct. Okay, let's see question number 13. Okay, gas range X contains 100 centimeter cube of hydrogen bromide gas HBr, and gas range Y contains 100 centimeter a cube of carbon dioxide. Now if you see, they both have the same volume and they both are gases, right? So the volume of each gas is measured at room temperature and pressure. Which statement is correct? Now let's see one by one. The mass of HBr is less than the mass of carbon dioxide. How you will know? You just have to calculate from your periodic table and you will see what is the molar mass of HBr. It's 81 gram. The molar mass of carbon dioxide is 44 grams. So of course HBr is more, it's not less. So option A is wrong. Now let's see for option B. The number of molecules of HBr equals the number of molecules of carbon dioxide. If you see the number of molecules, of course it will be same. Why same? Because their volume is same and they both are gases. So at standard room temperature and pressure, if the volume is same for the gas, then they have the same number of the molecules, not atoms but molecules. Okay, so this option is a right option. The gas in syringe X contains more atoms than the gas in syringe Y. So more atoms, now that's we have to check, because here now they are asking about the atoms. So if you see X, how many atoms it have? 2 atoms. And Y, how many atoms it have? 3 atoms, carbon dioxide, right? So who has more? Of course, Y has more, but they say X has more, so that's wrong. The number of moles of HBr is more than the number of moles of carbon dioxide. Again, it's wrong because it is contradictory with this statement, option B. Because if the volume is same for both the gases at room temperature and pressure, then they have the same number of the moles, right? 24 dm cube is actually for the 1 mole of a gas. So it means both of them have 100. So it means they have same number of moles. It should be less than 1 mole, but of course they will be same. So option D is also wrong. So we are just left with option B. That's why option B is the right option. Question number 14. 2.56 of metal oxide MO2 is reduced to 1.92 of the metal M. What is the relative atomic mass of M? So how we can find the relative atomic mass of M? It's simple. We just have to use the same formula. Moles is equal to given mass divided by molar mass, right? So we have to find the molar mass now. This one is missing. How we can find? You should have both of these things. But now we have only given mass. If you see, we have given mass, that is 1.92 gram of metal. So if you see, MO2 is reduced to 1.92 gram of metal. MO2 was reduced to M and oxygen, right? So this one is how much? 1.92. MO2 is how much? 2.56. So now what we can do, for oxygen we can find first the moles, and then from the equation we can see that how many moles of M we need, right? So if you want to find the O2, we will use the same formula. The number of moles we don't know, right? We have to find. Given mass we don't know here, but we can calculate 2.56 minus 1.92. So what will be the mass of oxygen? That is 0.64 gram. Now once you know the mass of oxygen, you can easily calculate the number of moles. Just reshuffle this one. 0.64 divided by 32, you will get 0.02 moles of the 0.064 divided by molar mass. We already know it's 32, so you will get 0.02 moles. Now we know that oxygen moles we need is 0.02, right? So if you know that oxygen is 0.02, so one oxygen molecule is one atom of the M. So of course the mole numbers will be equal now. So if you need 0.02 moles of the oxygen, you also need 0.02 mole of the M. So that's why now we know the moles of the M, right? So we can simply now calculate again. Moles we already know. Now we also know the given mass, that is 1.92. So we can easily find the molar mass. So when you reshuffle this a formula, you will get what? You will get this answer. So the relative atomic mass of M is equal to mass divided by moles, and if you calculate this one, you will get 96. So 96 is actually the atomic mass of the M. Okay, so 96, option B is the right option. Question 15. The equation for the decomposition of calcium carbonate is shown. Okay. What mass of calcium oxide is produced when 10 gram of calcium carbonate is heated? These questions are very important. They come in exam very often, and I will give you the trick how to solve this one. In these questions, you don't have to find the moles. Okay. You just can easily calculate through the mass. First of all, you have to see which two things they are talking about. If you see what mass of calcium oxide, it means they are asking about calcium oxide, and what they have given you about the calcium carbonate, so it means these are the two things that are our target, right? We don't have to consider carbon dioxide. Now let's see one by one. First of all, you have to find their molar mass. Okay, molar mass of both of these one. First, from the periodic table. So if you see, the molar mass of calcium carbonate is 100 gram, and for calcium oxide it is just 56 gram, right? So these both are 1 mole, right? So 1 mole is actually producing 1 mole of CaO, right? So 1 mole has a mass how much? 100 gram. So 100 gram is producing how much? 56 gram of the CaO, because they are asking about the grams. So now if 100 is producing 56, then 10 gram will produce how much? That is the question. So you just recross them and then you rearrange. So 100 into x, this is our x, in 10 into 56. So what will be your answer is, it will go here, and then what you will get? 5.6, right? So 5.6 gram is your answer. That is option C. Okay, this is how you can easily calculate. You don't have to find the number of the moles. You just have to see you have to just rearrange this equation, and then you will get your final answer. Question 16. This question is also same like question number 15. You have to find the mass. Okay, so mostly the question will be what mass, and they will give you another mass. Okay, so if for these type of question you have to use this trick. So now we already know that which we have to okay, we have now four elements and compounds here, okay, together. So magnesium sulfate and magnesium, these are the two things we have to find. So these are our target, magnesium and magnesium sulfate. Now let's see one by one. You have to find the molar mass of all of them. Magnesium has a relative atomic mass 24, so we already know. So but for magnesium sulfate we have to calculate. Yeah, so what will be the mass of magnesium sulfate? We have to calculate this one. That is 120 gram. Okay, 120 gram. So now if you see that magnesium 24 is producing 120 gram, right? So how much will be formed when 6 gram of magnesium react? So 6 gram of magnesium will produce how much? That is the answer we have to find. Just recross them and then you have to find your exact answer. 120 into 6, and this 24 when will be divided here, you will get your answer, and you can see your answer by calculating it. Okay, and the answer will be 30 gram. You will see 30 gram is the right option. But you can also use the molar formula, but I will suggest that don't use it, will take more time, so it's better just do the recrossing. Okay, so that's the best option you can do, and then you will get your answer. The answer of for this question will be actually 30 gram. Okay, so 30 gram is the right option, option C. Let's see question 17. Same question, same repetition. You just have to use the trick which I already have told you, that first you have to find their molar masses, right? Because, and what is the molar mass we have to find? Because what are the main compounds now they are talking about? One is magnesium carbonate and the other one is magnesium oxide. So it means these are our targets now. So again, find their molar masses. We already know the molar mass of MgCO3, that is 84, and for MgO it's 40 gram, right? So now what we have to do, simple. If 84 gram is producing 40, right? So how much of 5 gram will be produced, right? So now you have to be very careful in this one. Don't, because MgCO3 is here and MgO is here. So 84 is producing 40, right? Then how much magnesium carbonate is needed? How much is needed to make 5 gram of the MgO? So just recross them and then you will see 84 into 5 divided by 40 is equal to your answer. So what will be your answer? The option D is the correct option. If you calculate this, you will get 10.5 gram, and 10.5 gram is the right answer. Okay, let's see question 18. The question 18 is same like question number 17, but there is only one difference. In question 17, if you see, we have 1 mole was producing 1 mole of our product, whatever was asked in the question. But here they are asking you about the maximum mass of sulfur dioxide and iron sulfide. Okay, these are two of our targets in this equation. So where is iron sulfide? Iron sulfide is here, right? And sorry, iron sulfide is here and sulfur dioxide is here, right? So now if you see how many iron sulfide has been produced, has produced how many sulfur dioxide? 4 iron sulfide has produced 8 sulfur dioxide. So let's see, if you find the molar mass of iron sulfide, it is 120 gram, right? And for sulfur dioxide, it is 64 gram is the mass. But now you cannot use them directly, because if you see in the equation, 4 iron sulfide are making 8 SO2. So you have to multiply 4 with 120. That is your actual mass now. And for SO2, 8 into 64, that is your actual mass. Now you can cross them with each other and you can find the right answer. So if you see, you have to write first FeS2 and then you have to find here SO2, because this is your product. So FeS2, how much we need? 480 gram. And 480 gram is producing how much of the SO2? It is 512 gram. Now they told you 120 kg of iron sulfide. So 120 kg means 120,000 grams. So your unit should be same. Will produce how much of SO2? So you just have to cross them with each other and you will see the answer. So 480 gram multiply by this X and then 120,000 multiply by 512 gram, then this 480 will comes here and then you can calculate your answer. And when you will calculate your answer, you will see the answer option B is the right option. 128 gram is the right answer. Question number 19. Phosphorus react with oxygen to form phosphorus is the same question, the same tricks which I already have given you. You just have to find the molar masses of those compounds or elements that are asked in the question. Which mass of phosphorus oxide? It means you have to find the molar mass of P2O3, okay, and phosphorus, right? So phosphorus and phosphorus oxide. So these are our targets now. So you have to find the molar mass of phosphorus, that is actually 31 gram, right? But 31 into 4 because they are 4 moles, right? And for P2O3, it's just 2 into this mass. So what is the mass? It's 110. So 2 into 110 is 220 gram, right? So now you can reshuffle them. How you will reshuffle them? I already told you phosphorus and then you have to write P2O3, right? Phosphorus, how much? 124 gram, right? And it is producing 220 gram. So now 6.2 gram, if you have phosphorus, then how much you will be producing this one? You just have to cross multiply and then you can see your answer, 220 gram into 6.2 gram and then divided by 124 gram, right? So your answer, you have to calculate your answer and you will see option C is the right option. 11 will be the answer. So I hope these questions are clear to you. This is also the same, so I will not repeat again. You have to do the same. These questions also same like question 18, 19, 17. All of these questions are same. So you can practice this question yourself. You can pause the video and you can see that what will be your answer. So the correct answer for this question is option C. 7.2 gram will be the answer. Okay. Same. Let's see now question number 21. Question 21 is also the same one. Okay, so you have to just calculate the tricks which I already have told you. You have to find the molar masses and then you have to reshuffle them, same like in the math questions we do. So you will get your answer, that is option A. 22 gram will be produced. Okay. Question number 22 now. Let's see, this question is similar or it's different. Let's see. Okay, one by one. Okay, yeah, again the question is same. They have asked you about the calcium carbonate, okay, and dilute HCl. So now 10 gram of calcium carbonate is reacted with an excess of dilute hydrochloric acid. which mass of carbon dioxide is produced. So actually they are asking about calcium and carbon dioxide. So calcium carbonate and carbon dioxide. So these are our targets. So 1 mole is producing 1 mole of, so it's simple. You just have to find their relative atomic masses. So you see what is the molar mass for calcium carbonate? It's 100 gram. For carbon dioxide it's 44 grams. So if 100 is producing 44, so how much will be 10 will be producing how much? It's simple. You just have to reshuffle them and you will see the C option will be the right option, 4.4 gram. Question 23, again it's the same question, same repetition. You just, if they give you a mass, okay, and then they ask you the mass for another compound in that reaction, simple formula, I already told you, just use those formula, that you have to find the molar masses first and then you have to reshuffle all these molar masses by comparing them and you can get your answer. So option D will be the right option. Question 24. Sodium hydroxide undergoes the thermal decomposition. What is the maximum mass of sodium carbonate that can be made from 0.1 moles of sodium hydrogen carbonate? Now there is some change in the question. Before they were usually giving you the mass, right? But now they are giving you the mole. So now they are already giving you the mole, so you cannot use that mass trick. I told you. So here what you will do, you have to just compare the moles. Now if you see what is the target actually and what are the compounds they are asking about, we have to find that one. What is the maximum mass of sodium carbonate? So they are asking about sodium carbonate that can be made from 0.1 moles of sodium hydrogen carbonate. So these are our two targets. If two sodium hydrogen carbonate are making 1 mole, right, of sodium carbonate, then 0.1 mole will produce how much? 0.1 mole of course will produce 0.05 mole, right? Okay, because you have to make it half. 2 is making 1, so 0.1 will make 0.05. Now you already know the moles, right? They have told you, but you have to find the maximum mass of sodium carbonate. Simple. Use the formula of moles is equal to given mass divided by molar mass, right? So here you have to find the given mass. Moles is already given. Molar mass we have to find from periodic table. Just so what will be now the formula? The formula for given mass will be moles into molar mass, right? So moles is 0.05 and molar mass for sodium carbonate is how much? Actually 106 gram, right? So 106 gram when multiplied with 0.05 you will get 5.3 grams. So option B is the right option. Question number 25. Chlorine gas will react with the iron metal. Exactly 21.3 gram of chlorine reacts with 11.2 gram of iron. How many iron atoms react with 30 molecules of chlorine? So it's simple. They have given you the mass now here. Now they are asking about the number of molecules, right? Remember that we are also doing previously the molecules. Whenever they ask you how many atoms, how many molecules, so they are actually related to the Avogadro's constant. And whenever you are relating any question related to Avogadro's constant, you have to find the number of moles, because you cannot differentiate that is it equal or not, right? Because their masses are different. So first we have to find the number of moles. How much moles of chlorine and how much moles of iron are actually used. So now if you calculate, how we will calculate? The moles is equal to given mass, right, divided by molar mass. It's simple. So you have to find both for iron and for chlorine. So given mass is how much for the chlorine? It's 21.3 gram, and its molar mass, because chlorine usually exists in diatomic molecule, you cannot write 35.5 gram. Remember that. You have to write 71 gram. You have to multiply with 2 because in nature chlorine exists as a diatomic molecule. Now let's see for iron. But iron is a metal, so it will exist as an atom. We have to write an atom. So iron, if you see the mass of iron in the periodic table, it's 56 gram, and we have to, the given mass is 11.2 grams. So you just have to find now the moles. So if you see the moles of chlorine is 0.3 mole and moles of iron is 0.2 mole. So what does it means? If you see the ratio, that 3 chlorine moles will react with 2 iron, right? 2 iron atoms. That is the ratio. So here they already have given you, if you have 30 molecules of chlorine, right? If it is 30, then how much iron you need is simple, 20 molecules. So you need 20 iron, sorry, not 20 molecules, 20 iron atoms, because iron is an atom. So you need 20 iron atoms. It's simple. So 20 is the right option. That is option C. Okay, so option C is the correct option. Question 26. What is the concentration of a solution that contains 25 gram of NaOH in 500 centimeter cube of water? Now remember, they have given you the volume, right? Also, they have given you a mass and they are asking you about the concentration. So remember the formula. What is the formula for the moles? Moles is equal to concentration into what? Concentration into volume, right? We already know the volume, that is 500 centimeter cube, or you can say 0.5 dm cube. You have to find the concentration, but what about the moles? We also don't know about the moles. Okay, but if you see here, we have given an extra information, that is 25 gram of NaOH. We can use this one to find the moles. How we can find the moles? For you have to use the first formula that was for solid, right? Given mass divided by molar mass, right? Given mass we already have 25 gram. What about the molar mass? We can just calculate for NaOH, and NaOH molar mass is 40. So if you divide it by 40, you will get 0.625 moles. Simple. 0.625 mole you already know. Now we will just put it here, 0.625, right? So once you put it here, you can easily calculate. This one will come here. We will divide it by here. 0.625 divided by 0.5, and then you will get the concentration, that is 1.25 mole per dm cube. So you see, in all these questions up till now, I am just using the molar formula. No new formula has been used yet. And these are all the past paper questions. So you have to remember those 3 formulas which I have showed you for the molar, to find the number of moles. Okay. Now let's see question number 27. An experiment was done to determine the formula of hydrocarbon. 10 centimeter cube of gaseous hydrocarbon was burned in excess of oxygen to form 20 centimeter cube of carbon dioxide and 30 centimeter cube of the water vapors. So if you see the CX and HY, it's a hydrocarbon. When they are burned, what they are producing, actually they are producing carbon dioxide, CO2, right? But how much is the mass, and how much of the water? So water and carbon dioxide was produced when it burns with the oxygen, right? So carbon dioxide, if you see, it was 30 centimeter cube, right? Its volume is 30 centimeter cube, but for water it was how much? Sorry, the carbon dioxide was 20 and water was 30 centimeter cube. Now, if you see this question, from where this carbon is coming from, this carbon is actually coming from this hydrocarbon, and this hydrogen is also coming from this hydrocarbon, and these oxygens are from actually from oxygen. So let's see one by one. So 1 mole, when it is burned, it is producing 20 centimeter cube. So what does it mean? So 1 hydrocarbon, actually CH, is giving you 2, right? 20, or we can see 20 particles of the carbon, but 1 CH is giving you how much particles of the hydrogen? It's actually 30, right? So you just have to find now their actual number, the mass. How you can find the mass? Let's see one by one. So 20 carbon. So if you see for, sorry, it's mistake. So 1 CH will give you how many carbons, and 1 CH will give you how many hydrogen? 30. Now let's see the mass. Hydrogen mass is 2, right? Because there are 2. So 2 multiplied by 30 is equal to how many we will get? We will just get, because 2 atoms, so it will be 60, right? But carbon is just 1, so we will just simply get 20 carbon, right? 20 carbon will be produced, but here we will get 60 atoms, right? So 60 atoms of hydrogen and 20 of the carbon. So if you find the ratio of 20 to 60, what will be the ratio? It's 1 ratio, if you see, it's 1 ratio 3, right? So 1 ratio 3 is the right answer. So the formula will be CH3, or you can say this will be the empirical formula. But if you see the molecular formula, it will be C2H6. If you just cross the 0, 0, right? So C2H6, of course, you cannot find CH3, right? Then CH3 is empirical formula, and then molecular formula will be C2H6. Can you find the molecular formula? Yes, C2H6. So option C is the right option. Question number 28. Four fertilizers are each supplied in 100 kg bags. Which fertilizer supplies the greatest mass of nitrogen per 100 kg bag? Simple. You have to find the molar masses of all these one first, and then you have to find the molar mass of nitrogen. Once you find the molar mass of nitrogen, you just have to compare them, that how much is the mass. So if you see the molar mass of ammonium nitrate, what is the molar mass of ammonium nitrate? That is 80 gram, right? And in 80 gram, how many nitrogen we have? Two nitrogen molecules. So two nitrogen atoms. Two nitrogen means 14 into 2. That is 32, right? So we have 32 gram per 80 gram in ammonium nitrate, right? Now let's see for ammonium phosphate. For ammonium phosphate, if you see the molar mass is 149 gram. And how many nitrogen we have? If you see, we have 3 nitrogen actually. So 3 into 14, what you will get? Here you will get 42, right? So how many we have now? 42 gram of nitrogen per how much? 149 gram of ammonium phosphate, right? You just have to calculate now the answers. And same we can do for this one. What is the molar mass of ammonium sulfate? Be very careful when you are calculating, because you have to look from the periodic table. Don't miss all these small numbers, because they will decide your exact answer. Okay, so the molar mass is 132 gram. And how many nitrogen we have here? Only 2 nitrogen. It means 32 gram of nitrogen we have per 132 gram. Now let's see the mass of urea. Urea mass is 60 gram, the molar mass. And how many nitrogen we have here? 2 nitrogen. Again, so it's 32 gram, right? So 32 divided by 60. So what will be your answer? You can see one by one. The percentage, you just have to multiply with the 100 and you can find the percentage, right? So the percentage, if you see, for the urea is the highest one compared to all these one. See, so that's why option D is the right option. So you just have to find the percentage. How? From the molar masses. You have to find the molar masses of all these, and also the molar mass of the nitrogen in each of these fertilizers. Okay, and then you can just find the percentage, and the exact answer is option D, because it has the highest number of the nitrogen present in it. Okay, let's see now question 29. Calcium carbonate is heated. Calcium oxide and carbon dioxide are formed. The equation for the reaction is shown here. Okay, 225 gram of calcium carbonate is heated until there is no further change in the mass. The yield of calcium oxide is 85 kg. What is the percentage yield? Again, for the percentage yield, if they have just given you the masses, you have to use the same trick which I told you in the starting questions, that when they will give you the mass of one and you have to find the mass of another one. Okay, so it's simple. First you have to find the mass of first you have to find which compounds you have to observe in this equation. They ask you 225 kg of calcium carbonate is heated, okay, and the yield of calcium oxide is 85 kg. So it means they are just talking about calcium carbonate and calcium oxide. We have to do nothing with carbon dioxide. Now let's find their molar masses. Calcium carbonate molar mass is 100 gram. Calcium oxide is 56 grams. So it means calcium carbonate, and then you have to find CO. Okay, so 100 gram is producing how much? 56 gram, right? So now how much you have burned? 225 kg. 225 kg will give you how much? You can change it to grams, so it will be 225,000, right? Just cross multiply and then see your answer. 100 into cross, okay, 225,000 into 56. When it will go here, you will get the mass of calcium oxide. So if you see it, you get 126 kg of calcium oxide. Now we are clear. This is from theoretical. But they are saying we didn't get 126 kg. They give you that calcium oxide was produced 85 kg. So what does it mean? It means it is less, right? So you have to just find the percentage yield. Percentage yield is simple. The percentage yield, how you can calculate? You can easily calculate from the theoretical mass, okay? And then you have to find the practical divided by the practical mass. Sorry, there is a mistake. Not theoretical mass, sorry. Practical mass, right? Divided by theoretical mass. So if theoretical mass, okay, and then multiply by 100, just simple. So practical mass, they have given you 85 kg, right? According to when they did the experiment, they get 85 kg. And what is your theoretical mass? We already have find it is 126 kg. So you just have to multiply this one with 100 and then you will get your answer. So the answer is 67.5%. So the percentage yield is 67.5%. Option C is the right option. Question number 30. The equation for the reaction of iron oxide with carbon monoxide is shown here. Again, what is the percentage yield of the iron when 16.8 gram of carbon monoxide reacts completely with iron oxide to form 8.96 gram of iron? So what is the question? They want to know the percentage yield of iron, right? And they have given you what? 16.8 gram of carbon monoxide. So now the main question is related to carbon monoxide and iron, right? So if you see 3CO are producing 2Fe, right? So simply you have to find their molar masses. First we have to find the molar masses. The carbon monoxide mass is how much? 28, right? 28 into 3 is 84 grams, right? And for Fe, what will be the molar mass? 56 is the mass of the iron, right? But we are getting 2 moles. So this will be the mass of now iron. So if you see carbon monoxide and this is your iron. So how many carbon monoxide, what is the mass of carbon monoxide we get for 3 moles? It is 84 gram. And what is the mass of iron? 112 grams. So it means 84 gram is producing 112 gram. So how much we will get from 16.8? 16.8 gram will produce how much? We just have to reshuffle these and you will see that 84 16.8, okay, and then divide this here, then you will get your answer, and the answer will be 22.4 gram of the iron, right? So we are getting 22.4 gram of the iron. This is according to the theory, but in question they already tell you that it just form 8.96 gram of iron. So now here you have to find the percentage yield. Simple. You have to multiply the smallest number, that is your practical answer, right? 8.96, and divided by your theory answer, that is 22.4, and then just multiply with 100, you will get 40%. 40% is actually the yield that you will get after burning carbon monoxide, after the reaction of carbon monoxide and iron oxide, okay? So only you will get 40% of the iron. So option B is the right option. Question number 31. So it's the same question again. You just have to find first the molar masses. Okay, I will not do this question. You can just try yourself. You just have to find the molar masses of the two compounds that are asked in the question. Let's see which they have asked you. Ammonia, right? It reacts with the copper oxide to produce copper. So they are asking you about the copper, percentage yield of the copper, and they have given you information about ammonia. Don't get confused with copper, okay? We don't need this one, copper oxide. So actually they are asking about the copper and ammonia, right? So just find their molar masses, ammonia molar mass, and multiply it with 2. And then copper mass and multiply with 3. So whatever your answer will be, you have to just calculate by using the cross multiplication method, and then you will see what will be the mass of copper you will get. Once you get the mass of the copper, you just have to divide this one, 26.4 gram, divided by the mass you have calculated, right? And multiply it with 100, and then you will get your answer. So option D will be the right option when you will do these all calculations, okay? So 55 is the right answer. Question 32. Same question, same repetition. I will not do it again. Okay, so you just have to find the same trick which I have given you. So you can try and you can solve this question yourself, and you will find that option C is the right option. These are all the questions from the past papers. So of course the question, most of the question, if they come from chapter 5, they will be related either to the percentage yield or they will ask you about the given mass. So both I have given you the tricks how you can solve them, and sometimes they can also ask you about the concentration. Okay, so percentage yield, you need to remember the formulas of the moles or the how to calculate them through the mass, right, by reshuffling them, by rearranging the masses, and you can find easily, and then you can find the percentage yield. Question 33. So now we are given question number 33. The equation for the thermal decomposition of hydrogen carbonate is already shown. Sodium hydrogen carbonate molar mass, sodium carbonate molar mass is already given. So now they are asking you which statement is correct. You have to see one by one. So if you see in an experiment, 2.1 gram of sodium hydrogen carbonate is heated, but not of all of it's decomposed. All of the carbon dioxide is collected, measured at room temperature and pressure. The total volume of carbon dioxide produced is 0.21 dm cube, right? So now they have given you the volume of carbon dioxide. They also have told you that 2.1 gram of sodium hydrogen carbonate was heated, right? So if you see what is the information given you here, molar masses, right, for both of them, and the volume of the carbon dioxide that was collected. If you see here, we have already given the volume of the carbon dioxide that was collected here. So in an experiment, 2.1 gram of sodium hydrogen carbonate is heated, right? So the mass of sodium carbonate produced, we have to find this answer. We have to do nothing with this one. So we know how many, what is the mass of sodium carbonate is produced 0.93. How we can find the mass? We just have to use the moles is equal to given mass divided by molar mass, right? Molar mass we already know for Na2CO3, right? But given mass we have to find that this one is right or not, and then you have to find the number of the moles, right? So what, but we don't know the given mass also, because given mass they are asking in the option, so we are not sure. Moles we also don't know. So first we have to find the moles, which we can easily find for any one of them. So which information is given? If you see in your question, they have given you the volume of carbon dioxide, and remember that at room temperature and pressure the volume of 1 mole of gas is 24 dm cube, right? So it's just we have to find now the moles of the gas, right? So mole of the gas is just you have to multiply 24 with the given volume, that is 0. Sorry, no, not this. Moles of the gas is actually, so the mole of the gas is actually, you, the more, how you can find the mole of the gas, you have to just divide it by the 0.21 dm cube, the mass, and then you have to divide it with how much? 24 dm cube, right? So when you will divide it with 24 dm cube, you will get your mole. If it was 24, you will get 1 mole of gas, but it is 0.21. Now when you do the calculation, you can do the calculation and you will find the answer will be almost 0.007 something, right? If you multiply this 0.07, we already know the moles, right? So if 0.007 is the moles for carbon dioxide, right? 1 mole is produced and 1 mole of sodium carbonate is produced. So if it is 0.007 is produced, then this should also be around 0.007. You can calculate it. Maybe I am wrong. This calculation you have to do yourself. So now you just have to multiply this 0.007 with the mass of sodium carbonate and you will get your answer. Okay, so what will be the mass, given mass? Moles into molar mass, you will find the given mass. Okay, moles into molar mass, you will find the given mass, and if you calculate it, you will see that 0.93 is the answer. So that's why option A is the right option. You can just calculate and you will see that 0.93 gram is the right answer. Question 34. The equation for the reaction between aqueous lead nitrate and aqueous sodium chloride is shown. This is the equation. If 100 centimeter cube of aqueous lead nitrate of concentration of 0.1 dm cube, 1 mole dm cube is reacted with an excess of aqueous sodium chloride, which mass of lead chloride is obtained? Simple. Simple. Now you are given with the solution. Now let's see one by one which information is given and which we have to find. First of all, they give you 100 centimeter cube of aqueous lead nitrate, right? This one. And also its concentration. They give you the volume, right? And also they give you the concentration. Okay, it reacts with an excess of sodium chloride. Which mass of lead chloride is obtained? You have to find the mass of lead chloride. So, first of all, what is the formula to find the mass of lead chloride? Simple. Moles is equal to given mass, right? Given mass divided by molar mass, right? Molar mass of PbCl2 you can easily find from the where? You can find from the periodic table, right? So molar mass we already know it is 278, but we don't know about the given mass. We have to find it, right? We have to find it from here. But we also don't know about the number of moles. So how we can calculate now the number of moles for this one, because we don't know, they have not given you the number of moles. So how we can find it? We can find it from here. PbNO3, because PbNO3 we already know that 1 PbNO3 into 2 is producing 1 PbCl2. So if you calculate the moles of the PbNO3, you can easily find the moles of PbCl2. So what is the, I already have told you that for the liquids, what is the formula for mole? Mole is equal to volume into concentration, right? So what is the volume? Volume is 0.1 dm cube, because this is centimeter cube. I already told you you have to convert it by dividing with 1000. So 0.1 dm cube multiplied by 0.1 mole of the dm cube, right? 1 mole dm cube, right, per dm cube. So what will be your answer now? 0.01 mole. So now you already know 1 mole is producing 1 PbCl2. So 0.01 mole will produce how much? 0.01. So now you already know how many moles you need. You already have 0.01 mole, right? So it's simple, 0.01 mole. So just you have to do what now? You have to reshuffle them and you can get your answer. So mass is equal to 0.01 multiplied by 278. So you can easily get your answer, and that is 2.78 gram. So it means how much from this concentration we will get 2.78 gram of PbCl2. Okay, so 2.78 gram, option C is the right option. Question 35. The equation for the reaction of the sodium with water is shown. Water is the what is the volume of hydrogen gas measured at room temperature produced when 18.4 gram of the sodium react with excess water? So now they are asking about the volume of hydrogen gas, right? And they have given you what? 18.4 gram of the sodium is reacting. So now these you have to multiply. So if 2 moles of sodium react, we get 1 mole of the hydrogen, right? So it means we have to calculate how many moles of sodium actually now are reacting. So simple, you have to find moles is equal to given mass divided by molar mass, right? Simple, use this formula. Molar mass for sodium, we already know it's 23, right? So we already know 23. Given mass is how much? It's already given for 18.4 gram. So what will be the moles now? So moles is equal to 0.8 mole of Na. Okay, so 18.4 divided by 23 is 0.8 mole. So what does it mean? If 2 is producing 1 hydrogen gas, then 0.8 will produce how much of hydrogen gas? 0.4 mole, right? So 0.4 mole we already know. Now what we have to find? We have to find the volume of hydrogen gas. Simple, you have to use the mole formula again, but for the gases. So what is the formula for mole for the gases? Mole is equal to what? Mole is equal to, you have to divide with the moles. Okay, sorry, the volume. okay, the given volume divided by 24 dm cube, right, at standard room temperature and pressure. So now we already know the mole. That mole is 0.4, right, but we don't know this one. So you just have to multiply 0.4 with your 24 and then you can easily get your answer. Okay, so now volume of hydrogen at room temperature and pressure will be how much? It will be almost, you have to calculate it through the periodic table. I hope it's right. Yes, mole is 0.4 and then you multiply them and you will get your answer. And the option A is the right option, that is 9.6. Okay. Okay, so you will get, when you will multiply them, you will get 9.6 dm cube. So option A is the right option. Question number 36. 25 centimeter cube of 0.1 aqueous sodium hydroxide is neutralized by 24 centimeter cube of dilute sulfuric acid. What is the concentration? Simple, we are already given the concentration and volume of sodium hydroxide, right? You just have to find the number of moles. Once you find the number of moles, you already have the what? You already have the volume, right? So from volume, you can easily find the concentration. So for this one, we already have given the information, so we can just directly calculate and we can find the answer. So if you see here, sodium hydroxide, how you can find the moles is simple. Moles is equal to volume into what? Volume into concentration. So concentration we already know, 0.1 mole per dm cube. What about the volume? Volume you have to just convert it into dm cube, that is 0.25, right? So what will be your answer now? 0.00250 moles. So now you already find the moles for NaOH, right? So you can now easily find for the moles, the concentration for dilute sulfuric acid. So now let's see for the concentration of dilute sulfuric acid. If you see 2 moles of NaOH, okay, so for sulfuric acid H2SO4, how much we have to do moles is equal to volume into concentration, right? So volume, how much volume we are given is 24.6, that is 0.246, right? And now we don't know the concentration. And how we can find the moles? We already know that 0.0025 moles is of NaOH. But whenever you write the equation for NaOH and H2SO4, you will see that you need how many? Sulfuric acid for 1 NaOH. Always 2 moles of NaOH are required for 1 mole of H2SO4 if you write the equation. So that's why, so the moles of H2SO4 will be half of this one. So what will be the half of this one? It is 0.00125. So now you already know the moles, you just have to multiply them and then you will see your answer. What will be the concentration? So 0.00125 and this will come here, it will divide here and you can easily get the concentration. So that will be your concentration for the H2SO4 and that is 0.0508. So if you can find it, this is the option A. So option A is the right option. Question number 37. A solution of ethanoic acid has a concentration of 2 mole per dm cube. Which statement about this solution is correct? So what you have to do, you have to find the concentration of all these. Now you see 20 gram of ethanoic is dissolved in 10 centimeter cube of the water, 30 gram. You just have to find the concentration is same or not. So what are you given with? You are given with 20 gram of ethanoic acid, right? First of all, you have to find the, because you have to find the number of the, you have to find the concentration here, right? It means you have to find that 2 moles are in 1 dm cube. If you want to calculate this one, you must know the concentration for each of them, okay? Because you have to compare the concentration of all of them. So to find the concentration, again, first you must know the number of the moles. How you will know the number of the moles? You can easily find it by the molar mass. So molar mass of ethanoic acid you have to calculate first. It is 60 grams. So once you find the molar mass of the 60 gram, it is right. Now let's see one by one. 20 gram. So 20 gram of ethanoic acid when dissolved. So you have to just use the formula of the mole is equal to given mass divided by molar mass, right? So given mass is already 20 gram. 20 divided by 60, what will be your answer? 0.33 mole, right? So it is 0.33 moles. So if you see 0.33 mole, how you can calculate the concentration? Simply, concentration formula is 0.33 mole divided by 0.10. This is your volume, right? You just have to divide with the volume, and then you will see the concentration is just 33.3 mole, right? That is not the same like this one. So per dm cube, it's not the same. Then you have to calculate for this one. You will calculate again, and then you will see the answer will be 2 mole per dm cube. Same answer. So you can easily find that B option is right. So for this one, how you have to do first? First, you have to find the number of moles, because once you find the number of moles, then you can find the concentration, right? So how you can find the number of moles? From first formula, which I told you, that moles is equal to given mass divided by molar mass, right? Then once you know the moles, you can find the concentration by following the second formula, that was moles is equal to volume into concentration, right? So volume you already have given here, and moles you have already find from this formula and this formula, right? So you have to just find the concentration. So mole divided by volume, you will be finding the concentration, and you can do for all these questions like this, and you will find that option B is the right option, because the concentration will be same like 2 mole dm cube only for the option B. Question 38. The Haber process is a reversible reaction. Okay, the reaction has 30% yield of ammonia. Which volume of ammonia gas is measured at room temperature and pressure is obtained by reacting 0.75 moles of hydrogen with excess nitrogen? So many of information has given over here. So for solving these type of question, you have to first find that which information is given, otherwise you can get confused. So first of all, we have to find which information is given. First of all, the information that is given is that we have 30% yield of ammonia, right? Then we have to find the volume of ammonia gas, right? So ammonia gas volume we have to find, but we know that the yield is 30%. Okay. And how much, what other information we are given? That 0.75 moles of hydrogen are reacted. So we are also given the moles of 0.75 moles, right? So now which information is complete here? If you see here one by one, we can find that we are given the moles of the hydrogen, right? So we can easily find the volume also for this one, and also we can find the information related to the ammonia. So now let's see one by one. From the equation, we can see here, right? 3 moles actually are giving you how many ammonia? 2 moles of ammonia, right? Our main target is related to ammonia. We have nothing to do with the hydrogen, because we have to find what volume of ammonia gas is used, right? We have to find the volume of ammonia. So to find the volume of ammonia, you need to remember the formula. What is the formula? Moles is equal to volume into concentration, right? So do you know about the moles? No. Do you know about the concentration? No. Do you know about the volume? No. That is the thing we have to find. Now let's see. First target, we can find the moles easily by this reaction. If you see here, 3 is giving you 2 moles, then 0.5 should give you how much? So 2 divided by 3 multiplied by 0.75, right? So how many moles it will give you? 0.5 moles. It means 0.5 mole of ammonia are produced, right? So you have to find the volume and concentration. Now we are just left with this one. Oh, sorry, not concentration, because it's a gas, so we don't have to look for the concentration. It's simple, volume divided by 24 dm cube, right? So volume divided by 24 dm cube, because it's a gas. So now we already know this one. But if you see in the question, they told you that the yield they get is only 30% yield of ammonia. If you directly do like this one, the answer will be wrong. Why? Because you are doing theoretical, but they are asking you the practical answer. So you already know that you get a 30% yield from 0.5 mole. Okay, so first of all, you have to find that answer, that how much moles actually are used. Okay, so in actual, if you are getting 0.5 of the moles are used to give you 100%, right? 100% of the yield. So you are getting now just 30% yield. So how much was of the ammonia was used? How many moles of ammonia was used? You can just cross multiply this one. So 0.5 multiplied by 30 divided by 100. And what will be your answer? It will be 0.15. Okay, so your answer will be 0.15 mole of NH2. Simple NH3, sorry. So now you already know that 0.15 mole of NH3 was used. So you can easily find now the volume. How you can find the volume? Just multiply 0.15 into 24 dm cube and your answer will be 3.6 dm cube. So that's the right answer. You can calculate it. Okay, so you have to first read all the questions carefully and find the information that is given you in the question, because every information is important. If you miss any of the information, your answer can be wrong. So 3.6 dm cube is actually 3600 centimeter cube. So that's why option A is the right option. Question 39. The equation for the reaction between calcium carbonate and hydrochloric acid is shown. How many moles of calcium carbonate will give 24 centimeter of cube of carbon dioxide when reacted with an excess of acid? So if you see, they all are gases or liquid or solid. But what is the main thing they are asking about? How many moles of calcium carbonate? So it means the question is related to calcium carbonate. Will give 24 centimeter cube of the carbon dioxide. So the question is related also to the carbon dioxide when reacted with excess of the acid. So if you see, 1 mole of calcium carbonate is giving you 1 mole of carbon dioxide, right? And what we have to find? We have to find the numbers of moles of calcium carbonate. And if you see, calcium carbonate is solid. So moles is equal to given mass divided by molar mass, right? So molar mass we can easily calculate for the calcium carbonate, right, from the periodic table. But we don't know about the moles, and this is the we have to find the moles, right? But we don't know about the given mass. So we have to calculate this one also, right? So how we can calculate? First, we can look for the information that is given, that is 24 centimeter cube of carbon dioxide, okay, is produced. So how it was produced? Simple, moles. How many moles of carbon dioxide is produced? We can find moles is equal to what? Moles is equal to, actually, for the gases, we need to know that moles is equal to volume divided by 24 dm cube, right? So what is the volume now here? 24. So if you convert it into dm cube, it will be 0.024, right? So 0.024 divided by 24, you will get how much mole? 0.01 mole, right? So it means 0.01 mole was produced of carbon dioxide. So now you don't need the mass or anything, because these two are same. 1 mole is giving you 1 mole of carbon dioxide. So how much you will get from how much of the carbon dioxide you will get from calcium carbonate? 0.01 mole. So it means you have used 0.001 mole. Okay, they will be same. So from here you can find this one. So where you can find this option? Option D. So it means 0.001 mole of calcium carbonate has produced 0.001 mole of carbon dioxide. So option D is the right option. Question number 40. 4.55 gram of zinc is reacted with 50 centimeter cube of 2.25 mole dm cube dilute hydrochloric acid. The equation is like this. So which volume of hydrogen gas is produced in this reaction? Let's see now what are the information given and what we have to find. We have to find the volume of hydrogen gas, right? So gas, we already know this formula, moles is equal to volume, right? divided by 24 dm cube. Sorry, it's not working. Mole is equal to volume divided by 24 dm cube. That's for the gases, right? Because hydrogen is a gas now. So we have to find, we know 224, we have to just find the number of moles. Then we can easily calculate the volume. Okay, so now let's see this information which is already given. For zinc, we are already given the mass. Okay, 4.5 is reacted with 50 centimeter cube of 2.25 of dilute HCl hydrochloric acid. So now we already know the HCl information. Okay, HCl is how much? Simple, we already know the concentration and we also know the mass. Concentration and also the volume. So it's simple. We can find first for HCl. So first for HCl, if you find the moles, how many moles of HCl are used, simple is the formula for the solutions, that it is concentration into volume, right? Volume we already know is 50 centimeter cube. What does it mean? It means 0.05 dm cube. Concentration is how much? 2.25, right? 2.25 is the concentration. 2.25, right? Mole per dm cube. So if you multiply them, you will get what answer? The moles will be 0.1125. So it means 0.1125 of the HCl was used, right? 0.1125 if HCl of the use, then we can find easily the moles of the zinc also. How we can find the moles of the zinc? Just because if you see here already, how many grams we get for the molar mass. So now this one we already know. Let's see, for the molar mass of the zinc is 65 gram. We can also find the moles of zinc easily from here. You can also find from here 0.1125 will use how much of the zinc? Okay, 0.1125 you can just, because this is one is using 2, so 0.1125 will use how much? 0.14, right? Sorry, 0.14, right? But if you see here, 1 mole reacts with 2 mole of HCl, so 0.07 will need 0.14 mole of the HCl, right? If you calculate from here. But you see we have only 0.1125 which we calculated. So it means which is the limiting reactant? HCl is the limiting reactant. That's why you have to calculate the molar masses separately for both of them. And also the number of moles. So the number of moles for HCl was 0.1125. So the moles for zinc was 0.07. How you can see, you already have given the mass, but you are not given the moles, right? So you have to divide with the molar mass. You will get 0.07 moles. Now once you get both the moles, you see which one is the limiting reactant you have to find. If one zinc is using 2, right? So then how many? 0.07 will need 0.14 of the HCl, right? But that's now wrong because we are getting only 0.1125. So it means the HCl will finish first during the reaction. So it is actually the limiting reactant. That's why we will use the moles of HCl, not the moles of zinc. That's why they have given you two different information. You have to first decide which one is the limiting reactant. Once now you know that 0.1125 mole of HCl is actually available and it is a limiting reactant, so we'll use the same moles to calculate for H2. So if 2 is giving you 1 hydrogen, then 0.1125 will give you how many hydrogen moles? Of course, 0.05625. So now you already know 0.05625. You just have to multiply with 24 dm cube and then you will get your answer. And your answer will be 1.35 dm cube. Okay, so these are two different, these are another type of the question in which they will give you two informations, one related to the gas or the solid, but they will ask you to find, they will not ask you, but they will just ask you the volume of hydrogen gas like for your product. But in the equation, if they give you two information and both are not the same, right, they are not using the same number of moles, then you have to find their moles separately and find the limiting reactant also. Okay, so these questions usually take more time, so you have to practice a lot for these questions. Question 41. A student mixed together 25 centimeter cube of 1 mole dm cube of hydrochloric acid and 25 gram of calcium carbonate. What is the maximum volume of the carbon dioxide that could be collected at room temperature and pressure? It's the same question like question 41. So what you have to find, you have to find the maximum volume of the carbon dioxide gas, right? This one. And what you are given, you are actually given the hydrochloric acid information and calcium carbonate, both informations for both the reactants are given. Now you have to find when they give you the information, so how you can find the trick of the limiting reactant, that in which question you have to find the limiting reactant. First of all, you have to see that which informations are given. If they have given you just two compounds information like one or two, then that's fine, you don't have to find the limiting reactant. But if you see in this question, they will give you the information of two reactants and one product, so it means you have to find now the limiting reactant. If they give you the information of two reactants, then you must have to find the limiting reactant, right? Here they have given you the information for both the reactants, right, from the question. So you have to find first the limiting reactant, then you have to find the volume of carbon dioxide. So first of all, which formula we have to use? Moles is equal to volume divided by 24 dmq, right? This is the formula for the gas, and that is the final formula we have to use. So what we have 24 dmq, but we don't know the number of moles, right? So that is our first target. We have to find the number of moles, then we can easily find the volume for these one. Okay, for hydrogen. Clear? So now one by one, first we have to find the moles. So we have to find the moles of the reactant, and then we have to find which one is the limiting reactant. That limiting reactant moles will be actually equal to carbon dioxide, right? So now let's find one by one the moles of HCl and CaCO3. Let's see. HCl, okay, moles is equal to, because it is aqueous solution, so the formula will be volume into concentration. What is the concentration? 1. What is the volume? Easily you have to first convert it into dm cube. So 0.025, right? Is it right? Okay. 0.025 is the concentration. Wait a minute. Let me use a calculator. Okay. So okay, 0.025 multiplied by 1. So what will be our moles now? 0.025, right? Now let's find the moles for the calcium carbonate. So for moles for the calcium carbonate, we have to use the mass divided by molar mass, right? So mass we are already given 25 gram. And what about the molar mass of the calcium carbonate? That is 40 plus carbon is 12, right? And oxygen carbonate, CaCO3, so oxygen is 16 into 3. So let's find the calcium carbonate mass. Wait a minute. Okay, 40 plus 12 and then 16 into 3 is equal to 100. So now calcium carbonate mass is 100. So how much we will get? We will get 0.25. Okay, 0.25. Now This is our mole 0.25 and this is 0.025. Now let's see one by one. Okay, 2 HCl is using how much calcium carbonate? 1 calcium carbonate, right? So 0.025 should use how much? 0.025 divided by 2, right? But if you see here, 0.25 is the bigger number. So it means we have more calcium carbonate, but HCl is the limiting reactant. So now we already know HCl is the limiting reactant. So we will use our HCl moles to find the carbon dioxide. Now, okay, see, 1 calcium, 2 HCl is actually now giving you 1 carbon dioxide, right? So 0.025 will give you how much? 0.025 divided by 2, right, is the same. So what you will get, what will be your answer? How many moles of, you can also do calculation with me and you can see what is the answer. Okay, let's see the calculation. So 0.025 divided by 2 will be 0.0125. Now we already know the moles, that is 0.0125. It's simple, just multiply now 0.0125, 0.0125, we will just multiply it with 24 and what will be your answer? It will be 0.3 dm cube. So now your answer is 0.3 dm cube. All the answers here are in dm cube, or okay, so 0.3 dm cube, you can find it easily here. It is option D. So option D is the right option. So now I already give you the trick how you will know that you have to find the limiting reactant. If in the question they have given you the information of 3 compounds and from the reaction, and out of those 3, 2 are reactants. So if 2 of the information is about the reactants, okay, then you have to find the limiting reactant. But if there is only 2 compounds, they have mentioned the information is about 2 compounds and they both are reactants, or maybe they both are the products, then you don't have to find the limiting reactant. Remember that 2 reactant is not actually the trick. Actually, three compounds is the trick. If there are 3 compounds and 2 are reactants, then you have to use this trick of finding the limiting reactants. I will repeat again. 3 compounds information is given and 2 of them is actually reactants information. Then you have to find the limiting reactant. If you have only 2 compound information and both of them are reactants, then you don't have to find the limiting reactant. You just have to find the answers related to mole or volume, whatever they are asking about, okay? And even if they give you 2 products, then you just have to find the related to that one. You don't need to find for the limiting reactants. I hope this one is clear to you now. Question 42. Calcium carbonate reacts with dilute HCl. The equation for this reaction is shown here. 1 gram of calcium carbonate is added to 5 centimeter cube of 0.05 mole per dm cube of HCl. Which volume of carbon dioxide is produced in this reaction? Same question, same. You have to just find now that which, okay, how much information is given. So first of all, 1 gram of calcium carbonate. It means the information is given about calcium carbonate. Then hydrochloric information is given, HCl. Again, you have given the 2 reactants information, right? And which volume of carbon dioxide, and you have to find the product answer. So it means you have given the 3 informations, 3 compound information, and 2 of them are reactant and 1 is a product, right? So now in this question, you also have to find the limiting reactant. Okay, you also have to find the limiting reactant. So once you find the limiting reactant, how you will find the limiting reactant? By finding the number of moles of each. Which one? All of these 2 reactants, because the limiting reactant is from the, actually from our reactants. So once you find the number of the moles, you have to compare with this equation and you have to find the limiting reactant. Once you find the limiting reactant, then that limiting reactant moles you have to use to find the number of the carbon dioxide, okay? So of course in this equation 2 HCl, maybe hopefully it will be same. So HCl will be again the limiting reactant. So you have to use the moles of HCl to find the volume of the carbon dioxide. I hope this point is clear to you. So let's see what is the answer for this question. So the answer for this question is A, 30 centimeter cube. Okay, so you can do it yourself and you can find that. Did you get the answer 30 centimeter cube? Yes or no? Question number 43. An excess of zinc is added. Again, the equation for the reaction is this one. What is the maximum volume of hydrogen evolved at room temperature and pressure? These questions are very common nowadays in exams, so you have to remember. First, the moles questions. Second is the percentage yield question, and the third is the limiting reactants. Through the limiting reactants, you have to find the volume, right? So again, I think this is a limiting reactant, reactant questions. How? Because you see, they told you zinc is added to 100 centimeter cube of the hydrochloric acid, right? So hydrochloric acid is this one. Oh, they have not given you the information of the zinc, right? So it means this is not a limiting reactant question. They have just given you the information of HCl and they have asked you the volume of H2. So that's simple. Now you don't have to find for anything. You just find the number of moles of the HCl. Okay, simple. First, the number of moles of HCl. This is a simple formula. You can just find from the concentration. Okay, concentration into, sorry, volume. This is the volume and into concentration, right? So now you already get the moles for the HCl. So if 2 moles is producing 1 mole of the hydrogen, so how much we will get from 0.1? 0.1 will produce 0.05 moles of H2O, right? Simple. Now we already know the moles of H2, right? We also know the formula, that is moles is equal to volume divided by 24, right? We also already know 24. We also know the mole. So mole is 0.05. This 24 will come here and then you will get your answer, that is the volume, and the volume is 1.20 dm cube. So A option is the right option. Question 44. What is the volume of 14.5 gram of gaseous butane at room temperature and pressure? So here you have to find the volume of the gaseous butane. So what is the formula for the gaseous butane? Again, moles is equal to how much? Volume, okay, divided by 24 dm cube. You have to find this one, but we don't know about the moles of the butane. So you can use another formula because we already have given the information of 14.5 grams. So you can easily use the first formula, that is mole is equal to mass divided by molar mass, right? Given mass divided by molar mass, right? So what is the given mass? It's 14.5 gram. You just have to divide it with the molar mass, and the molar mass is 58 gram. You can see here. So you can easily get your moles. So the moles is 0.25 moles. Now you can use this value here, 0.25 mole. This 24 will come here. Just multiply with this one and you will get your volume. The volume of the gaseous butane will only be 6 dm cube. So where you can find 6 dm cube? Yes, option D. So option D is the right option. Question 45. The equation for the decomposition of ammonium carbonate is shown here. Okay, the total volume of the gas produced is 360 centimeter cube at room temperature and pressure. Which mass of ammonium carbonate is decomposed? So now they have given you the volume. Now here you have to find the mass. So what is the information given? Let's see one by one. So volume of the gas produced, the total volume of the gas produced is 360 centimeter cube. It means the total gases, how many we have here? Actually 3, right? They both are gases. So 3 gases are produced from how many moles of the ammonium carbonate? 1 mole. So if 1 is producing 3 gases, then 30 centimeter cube, we have to find the number of moles for the from this volume. Okay, so we already know that moles is equal to how much? Volume divided by 24 dm cube. Right now we already know the volume. Volume is 360 centimeter cube. Remember, we have to change it into dm cube. So how we can change it into dm cube? It will be 0.36 dm cube, right, divided by 24. So 0.36 divided by 24, what will be the moles of the gas? It's 0.015. So 0.015 now we have moles. So how many we have to use NH4CO3? Just divide by 3. Okay, so once you divide by 3, you will see that we will use 0.005 moles of ammonium carbonate. Right, now we already know the moles of the ammonium carbonate. We can easily find the mass of the ammonium carbonate by using simple formula: moles is equal to mass divided by molar mass. Right, so mass you have to find, just reshuffle this formula: moles into molar mass. Moles we already know now, 0.05005, right? And molar mass is already given in your question, 96. So just 0.005 multiplied by 96 will be your answer, and that is 0.48 gram. So 0.4 gram, 8 gram is the answer, B. So you see, only we are using which formula? We are using only the formulas for the moles. There are three different formulas that are used in all these questions again and again. And it is easy for you to find. How you can find? You just have to write in your exam first. Whenever you get the paper, write on your paper in center anywhere with the pencil, because you are not allowed to use a pen. So you can write these three formula with the pencil. Once you write these formulas, it will be easy for you to find that which formula you have to use. Okay, so always please revise these three formulas before the exams, and when you enter in the exam, write these three formulas on your question paper with the pencil, and after completing your answer sheet, you can just erase these formulas later. Okay, so it will be very helpful for you. This is a trick you can apply in your exam, and it will help you to get the full marks for all these calculations. So now let's see question number 46. A solution of sodium carbonate has a concentration of 0.03 mole. Which mass of sodium carbonate is dissolved in 1 dm cube of this solution? Again, now they have given you the concentration here, a solution of sodium carbonate, right? So first you have to find the molar mass easily. Moles you can easily find, and then you can find the sodium carbonate that is dissolved in 1 dm cube of the solution. So it's simple. Again, you have to repeat the same thing. So if you see the sodium carbonate, what is the solution of sodium carbonate? If you see, so sodium carbonate, you can easily find the moles, and the moles is equal to volume into concentration, right? So volume into concentration. So how you can find the volume and the concentration? Concentration is already given 0.03, right? Mole per dm cube, but volume you don't know. Okay, and the mass mole of the moles you also don't know. Now we have another formula, because they have given you two other information. So dissolve in 1 dm cube of this solution. Oh, they have given you the volume. So volume is 1 dm cube, right? So now moles is equal to how much? 0.03. 1 into 0, so it is just 0.3. So the moles is equal to 0.03 moles. Now you have to find the mass. They have asked you the mass. So now you can use the second formula of the moles, that is mole is equal to given mass divided by the molar mass. Right? Molar mass you can easily find from the periodic table. What is the molar mass of sodium carbonate? Of course, 100. And what is the given mass? You don't know. You have to find it, right? These. But moles you already have calculated. That is 0.03. Right? So 0.03 you have to find. So it will just come over here, and then you can easily calculate your answer. So 0.03, when you multiply with the 100, you will get which answer? Option B, 3.18 gram. Okay, so 3.18 gram will be your answer. So you can find the sodium carbonate, sodium bicarbonate is actually. So you can find the mass of this one, that how much is the mass. So it's not, I think it's not 100, maybe it's more. Okay, you can calculate it yourself from the periodic table. It's 23 into 2, and then you have to add 12, and then you have to 16 multiply by 3. So you can calculate the mass of the sodium carbonate, and you can see what is the mass of the sodium carbonate. I can try. Let's see how much we will get. 23 into 2, and then we have to add 12 is the mass for the carbon, and then we have 16 into 3. So it's 106. Yes, it's actually 106. That's why your answer will be almost 3.18 gram. Okay, you just have to multiply this. So it's simple. Now here you see we are just using the moles formula, but two mole formulas are used here. One by one you have to use them, and then you can easily find the answer. So a tablet contains 0.08 gram of ascorbic acid. What is the concentration of ascorbic acid when one tablet is dissolved in 200 centimeter cube of water? So now you have to find the concentration. And in which formula you can find the concentration? The formula is mole is equal to concentration into volume, right? So you already know the volume here. That is already given in your question. That is 200 centimeter cube of the water. So 200 centimeter cube means how much? 0.2 dm cube, right? 0.2 dm cube of the water we already know. You have to find the concentration, but we don't know the number of moles. So how we can find the number of moles? We have another extra information that is about the grams. So we can easily use that formula. Moles is equal to given mass divided by molar mass, right? Molar mass for ascorbic acid is already given 176. You don't have to calculate. Given mass is already 0.08 gram. So you can easily find the number of moles, right? So easily find the number of moles. This is now the answer for the number of moles. Once you find the number of moles, you can put this value here, 0.000545, right? And then just multiply with this, divide with 0.2, right? It will come here and it will do 0.2 dm cube. So what will be your answer? 0.00227 mole per dm cube. So can you find any answer that is related to 22.7? Yes, this is 2.3, right? Because it's one decimal place. So that is the right answer. So option D is the right option. Okay, so I hope it's clear. We are just using the moles formula, and two moles formulas are used according to the situation. Again, a known volume of the concentration of aqueous sodium hydroxide is titrated. The volume of dilute hydrochloric acid needed to exactly neutralize the sodium hydroxide is measured. 5 calculation steps are shown here. So what is the order of the step to calculate the concentration of the hydrochloric acid? Okay, so now first we have to answer this question. We have to see what information we are already given. So we already know the volume and concentration of aqueous sodium hydroxide, right? So what does it mean? We already know this information. Then volume of okay, is titrated against dilute hydrochloric. The volume of dilute hydrochloric acid needed to exactly. So we have to find the volume of HCl that is needed to exactly neutralize this sodium hydroxide, right? So once, if you see here, we have already given the information of the sodium hydroxide volume and concentration. So what will be our first step? Our first step is we have to find the moles of the sodium hydroxide, right? Because all the information related to moles is given for sodium hydroxide. So can you find the option for sodium hydroxide? Yes, this is. Calculate the amount of sodium hydroxide in moles, right? So this will be our first steps. Once you get the moles, you have to find the volume, right? So to find the volume, you also have to find the mole. So what will be the formula for the moles of moles is equal to volume into concentration, right? That's right. So but we don't know about the moles of HCl, right? And we have to find the volume. The volume is the last option, and we also don't know about the concentration, right? So but we already have find the option 1. So 4, can you see here? So 4, after the 4, the first step will be to find the moles of HCl, because from the moles of the HCl, sorry, so from the moles of the NaOH, now we already know we can find the moles of HCl, right? So HCl, finding the moles of the HCl, okay, that will be our second option, right? Once you find the moles of the HCl, now you have to calculate the relative formula mass, right? For HCl is equal to, moles is equal to mass divided by molar mass, right? You have to use this formula to find the mass. So how you can find the mass? You have to find the mass through the molar mass, You need to know the molar mass of now HCl. So now the third question will be related to, for the concentration, you have to find the, wait a minute. Okay, so once you know that first option is 4 and the second option is 1, if you can find here, this is only option C. But if you still want to continue, you can look for that what is the third thing we have to calculate. Now we can calculate the concentration easily because now we know the moles of HCl, yes, right? So we can easily find the volume by multiplying with the concentration, right? So concentration, how we can find, we don't know, but the volume HCl we already know now, right? HCl moles we already know here. So HCl moles, when you already know, you can find we can calculate the concentration of the hydrochloric acid in mole per dm cube. So this will be the fifth step we can find. The third step will be the fifth of statement, right? How we can find, because we already know the moles of the HCl here and the volume of dilute hydrochloric acid needed to exactly neutralize the sodium hydroxide is measured. Okay, the volume was measured, so it means they also give you the volume of the hydrochloric acid. The volume of dilute hydrochloric acid needed to exactly neutralize the sodium hydroxide is measured. It means we already know the volume, so volume we also know. So now moles we already have calculated, so we can easily find the concentration. So that can be the third step. And if you do want to find the next one is in mole DMQ, we already find, so we can calculate the relative formula mass later, and then we can calculate the concentration of the hydrochloric acid. That are the next steps, so we can do it later. Okay, so these are the steps that will come after that. So these are not mentioned over here, so you can just see that this should be in the right order. After that, anything can come, so option C is the right option. Okay. Question 49. The equation shows the complete combustion of the propane. Which statement is correct? Now we have to see again each statement one by one. So 10 centimeter cube of propane cannot burn if less than 50 centimeter cube of oxygen is present here. So when you are looking at these questions, they are talking about only the volume, right? And these are all gases. So now we can easily compare their moles because the question is related to the volume, and then we can easily find the moles. So from moles we can find that what is the right statement. If you see C3H8, right? And what we have to find, oxygen, right? So they are comparing two reactants. So 10 centimeter cube, okay, 1 mole need how many? 5 moles of the oxygen, right? So 10 centimeter of propane cannot burn if less than 50 centimeter cube of oxygen is present. Of course, if this become 10, then this should be 50, right? So this statement has a point. But the thing is, they say cannot burn. That is wrong. It will burn, but it will be incomplete combustion. If they say that 10 centimeter of propane will be incompletely burned if less than 50 centimeter cube of oxygen is present, then that's right. But they are saying that it cannot burn. It means there will be no burning. That's wrong, okay? So, but still, if you cannot find any option right here, you can consider this option as the right option. But we will see one by one all of them. 10 centimeter cube of propane would produce 40 centimeter cube of liquid water. If you see this 10 centimeter, okay, propane is 1, right? And 1 is giving you 40. Oh, sorry, 4 moles, right? It needs. But the question is that 10 can give you 40. You will say, yes, it can give 40, but this is the trick. The volume is only same for the gases. This one, propane, is a gas, but this one is a liquid. So the volume cannot be same. 10 cannot give you 40. We have to calculate. So that's why this option is wrong. Okay. Now let's see, for 100 centimeter cube of oxygen would be sufficient to react completely with 20 centimeter cube of propane. Now let's see again. So if this is 1 and we need 5 oxygen, so 100, for 100 how many we need? 20. Yes. So this option is right. It will be sufficient for 20 centimeter cube of the propane because both are gases, right? So volume should be same. Now let's see option D. This reaction would result in an increase in the volume of a gas. Okay, so when you do this reaction, how many moles of the gas you are actually using? 6 moles of the gas are used, right, in the reactant. But how many you are getting in the product? Only 3 moles. That's wrong. We are not getting an increase in the volume. It will be opposite. It will decrease. There will be a decrease in the volume of gas. So this option is also wrong, right? So we are only left with option C. So option C is exactly the right option. This option has ambiguity. Why? Because they have used the word cannot burn. It will burn, but it will be incomplete combustion. So if you compare both of them, C is the best option. That's why option C is the right option. Question 50. 4 gram of solid sodium hydroxide is added to water to make a solution with a concentration of 0.2. What is the volume of the water used? Again, you have to use again the two formulas, right? First formula, first of all, let's see which question they are asking about. They want to know the volume of water. And I already told you the formula of the moles in which we have a volume. So which formula is that? Mole is equal to volume into concentration, right? So the concentration is added to a water to make a solution with a concentration of 0.2 mole. We already know the concentration, that is 0.2 mole dm cube, but we don't know what. We don't know the moles because we have to calculate the volume, right? But we have to find the number of moles also. So what we have to do now, we have to find another option. That do we have any other information? Yes, we have another information that is about sodium hydroxide, that is 4 grams. So we can easily calculate now the moles of sodium hydroxide. So mole of sodium hydroxide is how much? It's the mass divided by molar mass, right? So mass is already given 4, and the molar mass of sodium hydroxide is how much? You have to calculate. It is 23, and then we have oxygen is how much? 16, right? And then one hydrogen will have this mass. So this is equal to 40, right? So 4 divided by 40 is how much? It's simple. It will be 0.1 mole, right? So 0.1 mole is your answer. You are already given with the concentration. Concentration is 0.2 mole dm cube. So moles you already know now, 0.1. So 0.1 divided by 0.2, you will get your volume, right? So the answer will be how much? Option C, 500 centimeter cube, or it will be 0.5 dm cube, right? So you can just change into centimeter cube because the answers are in centimeter cube. So it will be 500 centimeter cube. You see, we are using the same moles formula, but first we are using the concentration one, like, okay, and then we have to find that which things are missing. Then you can use another mole formula, and then you have to find the missing parts, and you can use them in the first formula. Question 51. Sodium hydroxide react with sulfuric acid. The equation is given here. Which volume of sodium hydroxide react with 50 centimeter cube of 0.1 mole dm cube of sulfuric acid? Now let's see one by one each information. Which information is given and which information we have to find. So now they have given you sulfuric acid and sodium hydroxide are reacting. Which volume of sodium hydroxide? So it means we have to find the volume of sodium hydroxide. So this is the first question you have to write. Whatever you have to find, you have to write that formula first on the top. So for sodium hydroxide, how we can find? Moles is equal to concentration into volume, right? So this is the thing we have to use for the NaOH now. So we have to find this thing, right? And we are already given 0.4 mole per dm cube. It means we are already given the concentration, right? But we don't know about the mole. That is the thing we have to find. Now let's see the second part. It reacts with 50 centimeter cube of 0.1 mole DM cube. Simple. Now for HCl, H2SO4, we have given all the information. We have to find the moles. Moles is equal to same, the formula, concentration into volume, because all the information is related to concentration and volume. Concentration is already given 0.1 mole per DM cube, right? What about the volume? Volume is how much, this is centimeter cube, you have to convert it into dm cube, that is 0.05. You have to divide it by 1000, right? So 0.05 dm cube. Now let's see what will be the moles. So the mole answer, if you calculate this one, how many moles you will get? You will get 0.05005 moles of H2SO4, that is here, okay? You can get the moles of H2SO4 is 0.005. So now it's simple. You can easily calculate for NaOH. 2 NaOH need 1 H2SO4. So how much we have already? H2SO4 0.005. So if 0.005 H2SO4 we have, how many NaOH we will need? Just multiply with 2 and you will get your answer. How many you will need? You will just need 0.01 mole. Now can I put this value here, 0.01 mole? Yes. So now we can easily calculate the answer. 0.01 mole you have to divide by 0.4, and what will be your answer? The answer will be in dm cube. You can see that is 0.025 dm cube. Okay, so that is your answer. All the answer given in centimeter cube, so you can just convert it again into centimeter cube and you can find your exact answer. Okay, that is 25 centimeter cube. So option D is the right option. So option B is the right option. So I hope this question is clear to you. You just have to use the mole formula. So you see, in all the questions we are using the moles formula one by one. There are 3 different formulas and we are using them again and again. So you have to remember these 3 formulas. Okay, now let's see question number 52. 25 centimeter cube of 0.1 mole hydrochloric exactly neutralized 20 centimeter cube of aqueous sodium hydroxide. The reaction is here. What is the concentration? Again, same question you have to do. You can do it yourself. I have given you the answers here. Okay, volume of HCl is given, concentration of HCl is given, volume of NaOH is given, right? So first you can find the moles of this one because everything is given here. So we just have to find the moles of the HCl. Once you find the mole of the HCl, you can compare the NaOH and HCl. So whatever will be the moles, for example, you find the mole is 0.025, right? So 1 is giving you 1 mole. So 0.025 will also give you 0.025 mole of NaOH. So you can easily find the moles of NaOH is also same, right? Once you find the moles of NaOH, simply use this formula. Moles is equal to concentration into volume. Concentration already given, right? Can you see concentration? No, sorry. Volume already given, right? Here. And moles you already have found it. So now you just have to find the concentration. Just take this here, divide it by moles divided by volume and you will get your answer. So option C will be the right option. You will get 0.125 after these calculations. Question 53. An excess of zinc is added to 100 centimeter cube of 1 mole HCl. The equation for the reaction is this one. What is the maximum volume of hydrogen evolved at room temperature and pressure? So which information is given and what we have to find? We have to find the volume of the hydrogen, right? How we can find the volume of hydrogen? Of course, it's a gas. Just use the formulas. Moles is equal to how much? Volume divided by 24 dm cube. This one we have to find, right? But this one we don't know, so we have to calculate this one. How we can calculate? Simply from here. 100 centimeter cube of HCl. So HCl volume is given, concentration is given. Just use the formula. Moles is equal to volume into concentration, right? And find the moles of HCl. So how many moles of HCl we find? It's 0.1 mole. So if zinc, sorry, not zinc, HCl is 2, 2 HCl is giving you 1 hydrogen gas, then 0.1 will give you how much? 0.05, right? 0.05 moles. So it's simple. Now I can put this 0.05 value here. This is dividing here, it will go here and it will multiply, right? When it's multiply, you will get your volume. Simple. So your volume will be 1.2 dm cube. That is option A. So option A is the right option. See, we are again, I'm telling you again and again, we are just using the moles formula. In all the question, we have just used the moles formula. You have to just reshuffle them again and again, okay? Question 54. A 0.5 gram sample of calcium carbonate is reacted with excess dilute hydrochloric acid. Which volume of carbon dioxide is produced at room temperature and pressure? So first is the first you have to focus on the question. Which question is actually given, right? So the which question actually they are asking. So volume of carbon dioxide you have to. It's a carbon dioxide is a gas. So which is the formula? Moles is equal to volume divided by 24 dm cube, right? So we have to find the volume now, right? But we don't know about the moles. So how we can find the moles? It's simple. You can find the mole from here. So we are giving the information of calcium carbonate now here. So, and the information is in the grams, right? So we will use the first formula, that is moles is equal to given mass divided by molar mass. Simple. Given mass is 0.5 gram and it is the mass of calcium carbonate. So we can just add the mass of calcium carbonate, that is 100 gram, right? So we can easily find the moles. So what will be the moles of calcium carbonate? It will be 0.05, right? So if you see 1 calcium carbonate is giving you how much carbon dioxide? 1. So 0.025 will give 0.005, sorry, will give you how much? 0.005 mole. Same. So you can put this value here. Now you know 0.005 also. You also know the dm cube. It will come here. It will just multiply here and then you will get your volume. Right? So what is your volume? It is 0.12 dm cube. So option A is the right option. Question number 55. Calcium carbide reacts with water to form ethine and calcium hydroxide. The equation for the reaction is shown here. Which volume of ethine is produced when 6 gram of water react completely with calcium carbide? Okay. So again, they are asking you for the ethine volume. So this is the volume you have to find, and this is a gas. So again, you have to use the formula of the gas. Mole is equal to volume divided by 24 dm cube, right? So now you have to find the volume, but you don't know about the mole. How you can calculate the mole? Easily, you can calculate the moles from H2O, because the H2O information is given. Moles is equal to how much? Given mass divided by molar mass, right? Now the given mass is 6 divided by 18. So what will be your mole? 0.33, right? These are the moles of the water. Now let's see one by one. 2 water moles are giving you 1 ethine molecule. So 0.33 moles will give you how much? 0.1665, right? You just have to divide by 2. So this is the mole number you will get. So 0.1665. Just multiply this one with 24 and you will get your volume. Simple. I hope these questions are clear to you and you can perform well in exams, right? Because I am telling you again and again, you just have to use those 3 formulas of the moles for solid, liquid and gases, okay? Now let's see question number 56. Sodium carbonate solution react with dilute HCl. The equation for this reaction is shown here. Now excess sodium carbonate is added to 10 centimeter cube of 0.1 HCl. Which volume of carbon dioxide is made? Again the same question. They are repeating the same question again and again, and you have to just find the volume of carbon dioxide. Okay, this is your question. And what is the information given? The sodium carbonate is added to this one. So the information is not about this one. Information is about HCl actually. Okay. So HCl, and then you have carbon dioxide. right? So if 2 is giving you 1, you have to find the moles of HCl from here. You can easily find it is 0.001 mole. So 0.001 will give you how much? 0.0005 of the carbon dioxide, right? So now you can easily find the volume of the carbon dioxide. Just multiply it with 24, right? And you will see that 12 centimeter cube is the answer, or 0.101 dm cube. So if you see your answer are in centimeter cube, you can just convert it and your answer is 12 centimeter cube. That is option A. So option A is the right option. Question 57, the equation for the reaction is shown here. 25 gram of calcium carbonate is reacted with an excess of dilute nitric acid. Which mass of calcium nitrate and which volume of carbon dioxide is produced at room temperature and pressure? So now we have to find the mass of the calcium nitrate. Where is our calcium nitrate? Yes, and we have to find the carbon dioxide, okay, volume. And which information is given? Only 25 gram of calcium carbonate, this one. So first we have to find the number of moles. So moles is equal to what? Given mass divided by molar mass, right? So if you already know 25 gram is the given mass, so what will be the molar mass? Molar mass for calcium carbonate is 100 gram. So what will be your answer? 0.25 gram or 0.25 mole, right? So we already know the moles of calcium carbonate are now 0.25 mole. So 1 mole is producing 1 mole of calcium nitrate, right? So 0.25 mole will also produce 0.25 of the calcium nitrate. It's simple. So now you can easily find the mass. So moles is equal to mass divided by molar mass, right? Just multiply the moles. Moles is 0.25 with the molar mass of calcium nitrate. Okay, and then you will get your answer. Simple. So mass of calcium nitrate you will easily get, and same you can do for this one. If 0.25 is the moles for carbon dioxide, right? 0.25 is the moles that is producing, 1 mole is producing 1 mole of carbon dioxide, then 0.25 will also produce 0.25 mole of carbon dioxide. So you just have to multiply 0.25 with the 24 dm cube and you can easily get your answer, okay? So what will be the answer? It will be 6 volume. The volume of carbon dioxide will be 6. So option A or C can be right. And from this answer, you can see, okay, from the moles answers, you can easily calculate the mass. And once you calculate the mass, you can see that which option is right, A or C. So option C is right. Actually, the mass of calcium nitrate will be 41 grams. You can do your calculation yourself, okay? Question 58, the equation for the reaction between sodium carbonate and dilute HCl is shown. What is the maximum volume of carbon dioxide produced when 26 grams of sodium carbonate react with dilute HCl? Okay, again, same question. You just have to find the volume of carbon dioxide. And what is the formula? Moles is equal to volume divided by 24 dm cube. Yes. And now we have to just find the moles. Then easily we can find the volume. So how we can find the moles? From here. This is the information given. Sodium carbonate. Simple. The moles of sodium carbonate, how we can find? 26.5 divided by the molar mass of sodium carbonate. And what is the molar mass of sodium carbonate? It is 106. So how many moles you get? 0.25. Right? So if 1 sodium carbonate is producing how much? 1 carbon dioxide. So 0.25 will produce how much? 0.25 moles. Right? You can easily write 0.25 here, multiply with 24 and you will see what is your answer, 6 dm cube. Simple. You will get 6 dm cube, that is option A. So option A is the right option. Question 59. The equation for the combustion of ethane is shown. Which volume of carbon dioxide is produced from 0.5 moles of ethane? Simple question. Again, you have to do what? C. You have to find the volume of carbon dioxide. It's a gas. Simple. Moles is equal to volume divided by 24 dm cube, right? So you just have to find the moles. How you can find the moles? Easily from the ethane, right? So 2 ethane is actually giving you 4 carbon dioxide, right? Yes. So now we have 0. So 1 will give you how much? 2, right? And if we have 0.5, then it will give you how much? 1 mole. It's simple, right? So you will get 1 mole. Okay, so now if you have 1 mole and you multiply this 24 here, your answer will be 24 dm cube. So carbon dioxide, how much carbon dioxide you will get? 24 dm cube. That is option B. So option B is the right option. Question 60, again the volume of carbon dioxide you have to find from 69 gram of potassium. Again they are asking about a gas. Again the moles is equal to, what is the formula? Volume divided by 24 dm cube, right? So volume you have to calculate, moles you have to find. How you can find the moles? From here. So potassium carbonate, the moles of potassium carbonate, how we can find? 69, the given mass, divided by the molar mass, and the molar mass is 138. So how many moles of potassium carbonate is used? It is 0.5 mole. So if you see here, 1 mole is giving you 1 mole of carbon dioxide. So 0.5 will give you how much? Of course 0.5 moles of carbon dioxide. So can you use this value here? Yes. 0.4 and then it will come here 24 and then you will get your volume. So this will be 1.2. Okay, 1.2, oh sorry, 12 dm cube. So 24 into 0.5 is equal to 12 dm cube. So can you find the answer 12 dm cube? Yes, B. So B is the right option. Let's see question number 61. Methane and steam react in the presence of a catalyst. 0.5 of the methane reacts completely with 0.5 mole of the steam. What is the volume of carbon monoxide and hydrogen produced measured at room temperature and pressure? So you have to find for both carbon dioxide and hydrogen, right? So because they are same, right? 1 mole is equal to 1 mole. 1 mole are used. So if you use 0.5 mole of the steam, then you are of course using 0.5 mole of the ethene also. So now you have to just find the volume of carbon monoxide and also for H2. So for finding the volume, you must know the moles, right? Moles is equal to volume divided by 24. So volume will be mole into 24, right? So how many moles of carbon monoxide is used? We have to see one by one. If you see, 1 mole is giving you 1 mole of carbon monoxide, right? So if you have 0.4 of the steam, right? So then it means you have 0.5 mole of the carbon monoxide, right? So you can easily, for carbon monoxide, you can easily find it. Mole is how much? 0.5. Just multiply with 24 and then you will get your answer. So for carbon monoxide, you can easily get that is 12 dm cube. So where you can find 12 dm cube? It's C and D. So option C or D can be right. Now let's see for the water, for the hydrogen. If one is giving you 3, okay, one water molecule is giving you 3 moles of H2, then 0.5 will give you how much? 0.5 multiplied by 3, that is 1.5, right? So now you have 1.5 moles of the H2. So H2 is 1.5 and just multiply with 24. What will be your answer? It will be 36. So where you can find 36 here? So option D is the right option. I hope this is clear to you that how we are calculating. It's just the moles formula we are using again and again, and we are all getting our answers related to volume, related to concentration or any mass we have to find. Just use the formula of the moles, okay? So these are all the questions which I already have covered from 2016 to 2024, and please remember my trick so you can save your time for this chapter. Okay, the question related to this chapter, because mostly 2 or 3 questions will come in the exam from this chapter. Okay, best of luck for your exam. I will come with a new video tomorrow. Bye bye.